Assalamualaikum. We all from group 5 will present our project application of first and second order linear differential equations. Our group member consists of Ahmad Samir, Muhammad Zulfadri, Muhammad Shahir, Muhammad Lukman, Nurul Humaira Aina and me, Siti Zainab. Next. Okay, for introduction, first order differential equation. The first order differential equation is the equation involve one or more derivative of differentiable function of a single independent variable. Application that we use for the first order differential equation is a process of canned food using Newton's law of cooling. The Newton's law of cooling is a popular application of the first order differential equation in the production line with temperature as the parameter. Heat transfer is the most important aspect of temperature management in the canning food processing industry. Newton's law cooling must be used to calculate the cooling temperature in relation to the ambient temperature, thus reduce the temperature in the cans. The objective of the first order differential equation application is to evaluate the use of first order differential equation. The aim was to find out what is Newton's law of cooling and to address the issue of the packing procedure when handling canned food. Okay, next.
Okay, for the result and discussions, we go through to the mathematical formulation. So the variable involved, we have two, which is temperature and times. Next, derivation of equations. dt over dt equal to k minus t, t minus m, and we calculate, we got tt equal to ce the power of kt plus 35. And then the general solutions, tt equal to cekt plus 35, and the particle solutions, tt equal to 40 e the power of negative 0.235t plus 35. Okay, this is the solutions. How to find time in 42 degrees. Okay, tt equal to 40 e the power of negative 0.235t plus 35, and we calculate, we got time equal to 7.42 minutes. Okay, on the right, we have one figures and two table. Okay, for the figure 1.31, graph of baseline process temperatures, and then we go through the table. We got two table. Table 1.31, temperature behavior depends to the time in the production line with cooling law. And then lastly, table 1.1 is temperature behavior in baseline production modification with respect to time. Okay, next.
Okay, so I will present about part B, which is the second order of differential equation. So the equation for second order differential equation is d power of y over dx square plus p bracket x dy over dx plus q x y equal to fx. So we got the variation of parameter and the undetermined coefficient. So in the second order differential equation, we use the application of RLC circuit. Okay, this help in locating the precise quantity of voltage that the RLC circuit needed in order to make the radio and TV functioning and work properly. A good RLC circuit means a good transmitter that can transmit information to people. Okay, the objective is to apply the second order differential equation to engineering application. Next, to understand the background of the problem and its importance. The third one is to evaluate the problem by using second order differential equation form. And the last one is to show variation of solutions and impact on engineering application through a graph generated from the equation. So the table you can see is the for undetermined coefficient. Okay, next.
Okay. Assalamualaikum. My name is Muhammad Luqman bin Muhammad Zabidi. My matric number is CD2102883. So, I will explain about the result, discussion, and conclusion. For the mathematical formation, this figure shows the RLC circuit used in radio as oscillator circuit mainly for tuning to select narrow frequency range from ambient radio wave. Given inductor L is 2 Hz, capacitor C 20 millifarads, and resistor R equal to 1.91 ohms. So from the question, we can get the variable involved is the first one is the voltage, and the second one is the times. From the variable involved, we can derivation of equation. We need to apply Kirchhoff current law. So the question is V over R plus 1 over L integral by limit negative infinity to t. V dt plus C dV over dt equal to 0. So the next one is d square V over dt square plus 1 over RV multiplied by dV over dt plus 1 over LC equal to 0. So we can get the S square plus 1 over RC S plus 1 over LC equal to 0. So from the equation, we can get to do the method of solution. So the method solution is R square plus 1 over 191 multiplied by 20 millifarad R plus 1 over 2 multiplied by 20 millifarad equal to 0. So this value we can get from the equation. So the next solution is Vt equal to C1 e power of negative t plus C2 e negative power of negative 25t. So we can get the three types of cases in RLC circuit, which is case 1 is L more than 4R square C. Second, case 2, L equal to 4R square C. And for the last one is case 3, L less than 4R square C. For discussion and conclusion, we get the three type of graph. So the first one is overdamped, so case for L more than 4R square C. So the second one is critically damped, case for L equal to 4R square C. And the last one is underdamped, is case for L less than 4R square C. So we can conclude that the application chosen for first order differential equation is Newton's law of cooling in manufacturing line. The significance of this application is to lowering the temperature at packing area. The application for second order is the RLC circuit. Is utilized in a radio as an oscillator to tune in the frequency range from ambient radio wave. This proves that the RLC circuit performs as a role that making sure in keeping a radio state function. A true calculation has been discussed for both applications. This graph will be used to compare its equation. So next. So lastly, this is our references and group member contributions. So that's all from my group, from group 5. Thank you.